All right, we're in section 1 still. And we are going to look at problem number 3. Problem number 3. Section 1 just has kind of a mishmash of problems in it. Not really anything that's like a pattern or anything. There's all different kinds of problems. Doing a little mathematical modeling, that is writing equations or something. So here we go. We've got a rectangular pizza, we got a large round pizza, they're the same thickness. Which option gives the most pizza for the money? What's your thought on that? It's a real life problem. You walk into the place, they have these two options. They cost the same. What are you immediately thinking? Which one gives me more, right? So find the area of each one. So we have a rectangle that's 18 by 24. So I should be able to do that. I'm going to use my calculator anyway. So that area is 432, and that would be square inches. So whatever it costs me, that's how much pizza I get, right? All right. Now, 24-inch diameter. So what is that area going to be?
144 pi.
It's going to be pi times radius squared. Which is 452.4. There's not a huge difference, but if you're being frugal, you'll buy the circular one because you get a little bit more for your money. Perfect. Easy, easy, easy. Number 4. Whoa, not quite so easy. Prove that 6 is a factor of n cubed minus n for all positive integers n. What? Prove that 6 is a factor of n cubed minus n for all positive integers n. So do you understand what that means? If you let n be 1, you get 0. Is 0 divisible by 6 evenly?
Yes.
Yeah, you get 0. There's no remainder, right? It's divisible. Well, what if we let n be 2? If we let n be 2, we get 8 minus 2, which is 6. Is 6 divisible by 6?
Yeah.
Yeah. Let's pick another number. Let's do 10. If we let n be 10, we have 1,000 minus 10 is 990 divided by 6. Yes. So it sure looks like it's true that that will always be divisible by 6 as long as you put in positive integers. But how do you prove that? Because we don't have time to, well, we couldn't do it anyway, right? You could start now and be as old as me, and if you just keep putting in numbers, you're never going to get all of them, right? So how are we going to prove this legitimately? Marin?
Well, I have a question first. So when it's saying that it's a factor for all positive integers, does that mean that, like,
6 goes into it evenly.
okay, so it couldn't, so it has to be a whole number?
What are the factors of 10?
5 and 2.
Exactly. Why are 5 and 2 factors of 10? Because they divide in evenly. A factor means you divide in and leave no remainder. Don't overthink it, Maria. It's what the factor has always been. Do you notice anything about this?
You can.
Okay, we can take an n out of it. Alright? And if we take an n out of it, we're left with n squared minus 1. Do you notice anything about that?
It's a difference of 2 perfect
It's the
squares.
difference of squares. Okay, now, I'm going to write those numbers in a little bit different, or those factors in a little bit different order. That's perfectly okay, right? I can do that. Now, I want you to look at these guys for a second. in this order now, do you notice anything about them? It goes up by one, which means they are consecutive. Aren't these consecutive numbers? So I have 3 consecutive numbers. I want you to think about that for a second. Like 13, 14, and 15. Or 22, 23, 24, or whatever. If you have 3 consecutive numbers, aren't you guaranteed that at least one of them will be even?
Yes.
And if a number is even, if I am guaranteed that one of these is even, won't that make it divisible by 2?
Mm-hmm.
If you have 3 consecutive numbers, aren't you guaranteed that one of them, exactly one of them, will be divisible by 3? Think about it, 3
Yeah.
consecutive numbers. Doesn't one of them have to be divisible by 3?
Mm-hmm.
So now I'm guaranteed that something in here is divisible by 2, and something in here is divisible by 3. Well, wait a minute. If a number is divisible by 2 and divisible by 3,
It's divisible by 6.
it's divisible by 6. Right. Mrs. Ford, how do I write that down? You write that down. This is an example of a problem where your solution isn't x equals 6 or 5 or something. Your solution is, because I have 3 words, because I have, and I'm not going to say it, you write it, you write it. The basic framework is, I have 3, I can factor this into 3 consecutive numbers. At least one of those is going to be even, and therefore divisible by 2. One of those is going to be divisible by 3, because every third number is divisible by 3. And therefore, being divisible by 2 and divisible by 3 means I am divisible by 6. Welcome to Honors Math, folks. I had a teacher once, test had, I forget how many questions, like 5 questions, but he worked them all. They were all worked. He handed us the paper, handed us a blue book. I don't know if you've ever seen that or not. It's just a little booklet full of empty pages, got the writing like an essay book. And one question, why? So we had to explain his solutions to these problems, and that's basically what you're doing here. You're explaining. You're explaining. All right. Again, these are just random problems. Here we go. Number 5. Right, according to the numerical model, which is simply the chart, don't let the vocabulary confuse you, what has been the trend in males joining the workforce since 1954? So what's happening to men in the workforce? Appears to be going down, right? Decreasing, going down, whatever you want to describe it. That's what it looks like, that's what's happening. In what 5-year interval, these are 5-year intervals here, did the percentage of men who were employed change the most? Okay, this is easy, you can figure it out, you just have to do a little figuring here. Where does it look like we went down the most? We're looking at men.
69 to 74.
I was looking at that one too. What is that drop?
What
Is
about
that
79 to
3.2?
84?
What about what?
79 to 84.
79 to 84 actually goes down 3.3. Did I do my subtraction right? Is 69 to 74 going down 3.2?
Yes.
And then 79 to 84 is going down 3.3. So I guess that would be the answer. Model the data algebraically with a linear equation of the form y equals mx plus b. Write one equation for the women and another equation for the men. Use the 54 and 99 ordered pairs to compute the slopes. Why do they do that? Why do they tell you which ones to use? Miranda?
Not all of the years and numbers are gonna have the same.
So if they didn't tell us that, then he's gonna get one answer, you're gonna get a different answer, I'm gonna get a different answer. So just to make it consistent, they're saying use 54 and 99. Okay, so women, the 54 is 32.3, and the 99 is 58.5. So they want you to write a linear equation. You know how to do that. And then they want you to do the same thing for the men. So 54 and 99. Okay. So hopefully you're finding the slope. Think of these as ordered pairs. Peter, you done already?
No,
Just don't sit there and let everybody else do the work. Put you on the JV bench. This is what I got for the women, and this is what I got for the men. So does it make sense that my man's slope is negative? Yeah, because we already observed those were going down, right? I don't like, when I'm modeling like this, I don't like to round off if I can help it. So I don't know what you did, but when I typed this into my calculator, it was some decimal. So I just used my math frac to change it into a fraction. I've done that before. You don't know how to do that? Take your calculator, where is it? You don't even have your calculator out, Sabrina.
You can do those in your head. right?
You can do these in your head, you're an amazing human being.
Thank you.
Alright, so when you do 26.2 divided by 45, which is what I got when I was doing my slope here, I got a repeating decimal. So, got a math button right here.
Mm-hmm.
The first option is frac, hit enter twice, and it pulls up the fraction in reduced form, right? You could also reduce it by hand at this point if you wanted to, but it's just easier with the calculator do it. All right, there are your mathematical, your what they call algebraic models. Explain why the percentages cannot continue indefinitely to follow the linear models that you wrote. So what that means is in my ordered pairs, X was a year and Y was the percentage, right? If I keep going with my woman model to 2050, 2098, 2215, if I just keep going through time with this model, what is going to happen to my Y value? It is going to become bigger than 100, right? I mean, obviously this can keep growing, but if these are percentages, they cannot grow past 100, right? Similarly, if I keep going with my male model, keep going, many years out, 2250 or something, many years out, what's gonna happen to that percentage? It's gonna be negative, and we know that can't be either. So, given the situation, clearly the models aren't perfect, because eventually they'll produce answers that don't make any sense. Can you explain this, by the way? This is real data gathered from some governmental website, well, we assume it's real. Can you explain it? What's going on?
Wasn't it like 1964, like women got something, were allowed to work, something in the workforce, I don't know, labor union, yeah.
Well,
Women.
I think women have pretty much always been able to work, but yes, we had the women's liberation movement where women started actually vocalizing that, hey, we're just as good as men. I don't want to demean, I don't demean any, my mother was a stay-home mom. Because in those days, that's the way it was done. Mom stayed home, raised the family, dad went out and farmed or did whatever dad did. We still have parents staying at home, but now, does anybody have a stay-home dad? There are dads who stay home now. That was unheard of when I was growing up. That would have been considered so weird back in those days. But now, dads stay home. Moms are earning more money, so dads don't have to have 2 jobs, right? I mean, there are lots of economic and social reasons for that. But yes, that's it. I have always worked, but I worked part-time part of the time because when my kids were little, it was just too hard. I couldn't keep up. And I couldn't pay daycare, it was too expensive. Somebody told me today, this morning in workout, somebody said that substitute teachers in Denver, now I haven't validated this, this was just a workout conversation. Substitute teachers in Denver, Colorado get paid like $235 a day.
What?
That's what she told me.
Wait, hold on, how much money is that?
Well, I don't know, because the first thing I said was, oh my gosh,
30 an hour.
I don't think I make that much a day.
Yeah.
And I'm grading papers and doing lesson plans and whatever. I gotta check this out and see if that's true. If I'm not here tomorrow, I'll be in Denver. So, all right, now we're gonna solve a couple of equations algebraically. What I mean by algebraically is not graphically. I know that you could solve this equation graphically. You could type this in, type that in, look where they intersect. I get that. We're not doing that. We're solving algebraically. Algebraically means with your pencil. All right, so you can use your calculator if you need help with arithmetic or something, but we're doing this old-fashioned. So what would you suggest here? This is an easy one.
Take the square root.
Both sides, absolutely. And when you square root, over here, it's gonna be plus or minus the square root of 121. So x equals negative 11 plus or minus 11. So our answers are 0 and negative 22. Could not be any easier. Check out the next one.
You can square everything.
Subtract x and then do the same thing. It's not gonna be quite as easy, but that's what I would do that. I would subtract the x.
Could he square everything and turn it into a quadrant?
Now, when you say square everything, you are allowed to square a side, you cannot square the individual pieces. Think about it. Is it true that 2 plus 4 is 6? If you square the individual pieces, does it work? No. If you square the sides, it works, but not if you square the pieces. So you cannot square the pieces and you cannot square root the pieces. You have to do it a side at a time. So this is where we're at. So what are we gonna do with this? Well, this is just x squared, or x, that's just x, right? And this is a FOIL, so it's gonna be 1 minus x, 1 minus x. So it looks like I'm gonna end up with a quadratic after all, just maybe not the quadratic you thought you were gonna end up with. So far, so good? Now what? Subtract the x, so 0 equals x squared minus 3x plus 1, does that look right?
Yes.
And what?
Quadratic equation.
Quadratic formula.
Okay, so it's a quadratic, either factor, complete the square, use the formula, right? This one doesn't factor, so I could complete the square, but this is gonna be a hassle because I have to divide by 2. So I think I'll just use the formula, but it doesn't make any difference. You will get the same answer if you decide to complete the square. I know some of you like completing the square the best. And that's perfectly okay if that's what you wanna do. All right, I'm trying to talk and write at the same time. Did I get that right? So 3 plus or minus root 5?
Yeah.
So x equals 3 plus root 5 over 2 and 3 minus root 5 over 2. Sydney?
So once like that, would you want us to explicitly write 2 answers, or could we just do the plus minus?
No, you never have to write 2 answers. I want you to consider both answers because remember, when you square both sides of an equation, you've gotta check or should check for extraneous roots. This is where we get extraneous roots because when you square both sides, any negative that was in the original problem is gone. And sometimes when you eliminate those negatives, you create bad answers, extraneous roots. So I separated them to make it easier for me to check. That's the only reason I separated them, okay? So now I gotta go back to the original problem and make sure that if I take the square root of that and add it to itself, it gives me 1. Okay, so I'm gonna check it right now. I'm gonna see if that works. So 3 plus the square root of 5 divided by 2. And I'm gonna square root that. That's the number that's right here. So I'm gonna square root that. And then I'm gonna, well, I don't even need to because the number I got, this right here, is about 2.6. So when I square rooted it, I got 1.6. If I add 1.6 and 2.6, am I gonna get 1? So guess what? That's extraneous. So now I'm gonna check the other one. 3 minus the square root of 5 divided by 2. That one is about 0.38. So now I'm gonna take the square root of that number and add it to itself. And guess what? That one works. When I do that, I get 1. So again, Sydney, when you do that operation, squaring both sides, you need to check, if you put 0 in, that's okay, get rid of this. And if you put negative 22 in, that's okay, that one checked, I kinda did in my head. This was a mess, so I split it up and went to my calculator. Does that make sense to you?
Yes, it does.
Yeah. So, if she wrote this in the answer blank, guess what? She's not gonna get full credit, cause not both of those work. When do we have to check our answers? When we square both sides. That gets rid of negatives, and that can cause problems. All right, one more, and that'll be a good break time. One more, number 7. Then 1.1 will be done, so that homework will be due on, where's my plan book? Friday. So we are period B, we don't need on Friday, put it up here. 1.1. All right, the graph below shows the distance from home for a jogger. Using information from the graph, write a paragraph describing the jogger's workout. So it's the distance from home. So let's just look at that one for a second. So time, let's say this is 1 o'clock and this is 2 o'clock, or let's do minutes. Let's say this is 10 minutes and this is 20 minutes. And this is, I don't know, 2 miles. This would be 1 mile, and so on, all right? That's the distance, that's the time. So what's happening? What does this mean? At 10 minutes, he's 2 miles from home? But at 20 minutes, where is he?
Back home.
He's back home. So what did he do? How are you gonna describe this? Because he did it again. He did it again.
He
So,
runs at a constant rate, 2 miles away, 10 minutes, then with that constant rate back home.
and then
Then the same thing.
goes back out. Now, these numbers were made up, so I don't know if you wanna reference those particular numbers or not. But what's the guy doing? Maybe, I don't know, running around the block or something? I don't know, he runs around the block, comes back, runs around the block again? Something like that is happening. Yep. And I like that constant rate thing. How do we know that's a constant rate?
It's linear.
It's linear. Very good, Oliver. It's linear. If he were running at a variable rate, it would be a curve. It's all about slope, right? If the slope is the same, it's constant. So his change is constant. Okay, guys, I'm gonna have you back from lunch at 49. And we're in our seats at 49, okay? Go team, and we'll start 1.2.